Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to design Microstrip Optimum high pass filter using HFSS software. So this is the layout of a Microstrip Optimum high pass filter. So in this design, I am considering the operating frequency is 1.5 GHz and type of the material is Rogers RT Duride 5880 and its dielectric constant is 2.2 and height of the substrate or thickness of the substrate is 1.57 mm and this length is substrate length is 150 mm and width is 30 mm. So this is the main transmission line and its length is 150 mm and these are the via whole grounds. So these are the inductive elements: capacitor element, inductive element, capacitor element, inductive, capacitive element, inductive, capacitor, inductor, capacitor, inductor, capacitor, inductor elements. So now open HFSS software. First draw the substrate, select the box, draw the box anywhere in the plane, give the rename of this box 1 substrate and set the type of the material. The type of the material is Rogers RT Duride 5880 and its dielectric constant is 2.2. So now change the dimensions of the substrate and X size is 30 mm and Y size is 150 mm and height of the substrate is 1.57 minus 1.57 and position X position is minus 15 mm and Y position is minus 75 mm, Z position is 0 mm. So click OK button, select fit all. So this is the substrate. So below the substrate we can design ground plane. Select the rectangular sheet, draw the rectangular sheet anywhere in the plane. Give the rename of this rectangular sheet. So this is ground plane. So the length and width of the ground plane is same as that of the length and width of the substrate. X size is 30 mm, Y size is 150 and position minus 15 mm, minus 75 mm and the ground plane is below the substrate. The height of the substrate is 1.57 mm. So now the Z position is minus 1.57 mm. So click OK button and rotate this structure and this is ground plane. So on the top of the ground plane we can design this is substrate. So on the top of the substrate we can design a Microstrip Optimum high pass filter. Select the rectangular sheet, draw the rectangular sheet anywhere in the plane. And change the dimensions of this element and the Y size is 150 mm and this width is 4.9 mm. 4.9 mm and position and X position is 1.1 mm and Y position is minus 75 and Z position is 0 mm. So click OK button. Okay, text size is I am considering minus 4.9. And after that design, these inductive elements. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane and change the dimensions of this rectangular sheet, and X position is 15 mm and Y position is minus 75 mm, Z position is 0 and X position is now here 75 plus 75 minus this length minus this width, inductor width 0.9. 75 minus this length, that length is 5.5 minus 0.9. So now where the Y position is 68.6. 68.6. Z position is 0. And X size is axis is the Z axis, and X size is now that strip length is 13.9 minus 13.9 and width is 0.9 mm. Select rectangular one, copy paste, press Ctrl C, Ctrl V, change the dimensions of this pasted rectangular sheet, and Y position is plus 65.6 and Y size is minus 0.9. Click OK button. Next draw this inductive element and this inductive element. So now here this strip X portion is Y portion is 68.6 and this length is 23.8. So this strip X portion value minus this length minus this strip width. So that is the X portion value of the next strip. Select the rectangular sheet, draw the rectangular sheet anywhere in the plane and change the dimensions of the and X sizes. So this strip length is 13.5 and width is 2.0. X size is 13.5 and width is 0.2 and X position is 1.1 mm and Y position is here 42.8 before indicating negative sign minus 42.8. Z position is 0 mm. Sorry, this the strip width is 2 mm, not 0.2, 2 mm. Select this rectangular sheet, press Ctrl C, Ctrl V. So pasted element of the Y portion is 42.8 and this Y size is minus 2. Click OK button. Next draw the next inductive element. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane. Now where the X position is and previous this element X position is 42.8. 42.8. So this rectangular sheet exposure can be determined. So 42.8 minus 23 minus 2.8. So this strip exposure value before indicating y position value, not exposure, y position, before indicating negative sign. So now here the strip length is 13.2 and width is 2.8 and x size is 13.2 and y size is 2.8 and x position is 1.1 and y position is minus 17 mm and z position is 0 mm. Click OK button and copy paste this rectangular sheet. Select this rectangular sheet, press Ctrl C Ctrl V and change the dimensions of the pasted element of the rectangular sheet. And this y portion is plus 17 mm and y size is minus 2.8. Click OK button. And after that, select main transmission line, that is capacitive elements and inductive elements, transmission line and rectangular 1, rectangular sheet 1, rectangular sheet 2, 3, 4, 5, 6. Press click unite button. Now set the lumped wire hole grounds. Select the cylinder, draw the cylinder anywhere in the plane and give the rename of the cylinder. This is via hole ground and I am selecting the type of the material is copper. We are selecting the type of the material is copper material and change the dimensions of the created cylinder. So I am considering the radius is 0.2 mm, 0.2 mm and length of the height of the substrate is 1.57 mm. So this height is minus 1.57 mm and position, center position and x position is 14.6 mm and y position is minus 16.15 mm. Click OK button. Okay, so this is via hole ground of the inductive element, first inductive element and select this via hole ground, press Ctrl C Ctrl V. So change the dimensions of the via hole ground element. Now where the y position is plus 16.68.15 and similarly draw the remaining Inductors are remaining elements of the via whole grounds. Design remaining things. Select the cylinder. So draw the cylinder anywhere in the plane. So give the rename of this one. This is via whole ground 2. Type of the material is copper. Change the dimensions and exposition is 14 mm and Y position is minus 41.8, Z position is 0 and axis, the Z axis radius of the cylinder is 0.2 and height of the cylinder is height of the substrate minus 1.57. Click OK button and select this via whole ground to press Ctrl C Ctrl V, change the dimensions. Now where the Y position is 41.8. So now select the cylinder, draw the cylinder anywhere in the plane and give the rename of this cylinder via whole ground 4. Material is copper and now here the X position is 13.7 mm and Y position is minus 15.6 mm. Z position is 0. Radius of the cylinder is 0.5 and height of the substrate. So minus 1.57. So click OK button. Select this via whole ground 4. Press Ctrl C Ctrl V. Change the dimensions of the Y position plus 15.56. Click OK button. And now select assign perfect electric boundary of the ground line and optimum microstrip high pass filter. And this is optimum microstrip high pass filter. Select this one and ground plane. Right click on that one. Go to assign boundary. Select perfect electric boundary. Click OK button. So this is perfect electric boundary. Now design the port. Rotate the structure. And this is X axis and Z axis. Change the plane. XZ plane. Select the rectangular sheet. Draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet. This is port 1. Change the dimensions of the port 1. So port 1 now X size is minus 3.8, Y size is minus 35 mm, Z portion is 0, axis is the Y axis, and X size is that is the width of the main strip transmission line, and that width is 4.9. So now where X size is 4.9, and Height of the substrate is 1.57, so Z size is minus 1.57. Click OK button. Copy paste this port 1. Now select port 1, right click on the port 1, assign excitation, select lumped port. Draw the new line integration from lower port to the upper port. So the lumped port excitation is successfully defined. This is port 1 lumped port excitation. Similarly, draw the lumped port excitation of port 2 and rotate the structure. Select port 2, right click on the port 2, go to assign excitation, lumped port. Draw the new line integration from lower port to upper port, successfully defined. So now coming back to XY plane. Now set the analysis setup, go to the simulation. So now the operating frequency is 1.5 GHz, maximum number of passes are 12, maximum delta S is 0.02, click OK button. And sweep type is fast and starting frequency is I am considering 1 GHz and ending frequency is 6 GHz and points are 101. Click OK button. Now create the open region boundary. Go to the model, right click on the model, create open region, click next button. So this is open region boundary. So now check the design validation, check validate button. So design is successfully validated and start the simulation. So now here this red color curve is return loss curve and green color curve is response of high pass filter.